Hi kids, welcome to Raw Math. In Raw Math, today we are going to discuss about rational numbers. Before going to what is meant by rational numbers, let us see what is meant by natural numbers. Natural numbers. Natural numbers are numbers which starts from 1, 2, 3, 4, 5, 6, etc. When we ask you to count, generally you will count it as 1, 2, 3, 4, etc. That is why we call it as natural numbers. Whole numbers. What is the difference between whole numbers and natural numbers? Both are same except only one thing, that is whole numbers has a extra number which is known as 0. Apart from 0, every numbers are the rest like natural numbers. Next we will see integers. Integers where it does not have a starting number or it does not have an ending number. Integers is represented as Z, capital Z, where integers is a set of positive and negative numbers with 0. Rational numbers. Now we'll come to the part rational numbers. What is meant by rational number? Rational number is also a type of numbers which will have all these three types of numbers: natural numbers, whole numbers, integers. With that, we'll have some other numbers also which is known as P by Q form. That is, numbers which can be represented as P by Q form, where P and Q are integers and Q does not equal to 0 is rational numbers. Let me say it again. Numbers which can be represented as P by Q form, where P and Q are integers and Q does not equal to 0 is known as rational numbers. Let us see an example. First, minus 3 by 2. Is minus 3 is an integer? Yes. Is 2 is an integer? Yes. Instead of minus 3, just put the letter P. Instead of the number 2, just put the letter Q. So minus 3 by 2 can be rewritten as P by Q. That is why minus 3 is a rational number, since minus 3 is also an integer and 2 is also an integer and 2 does not equal to 0. Is a rational number always will be in the form of P by Q? Yes, obviously, but few numbers will not be in that form. For example, let us take 3. 3 is also a rational number. How can you say that, sir? Because 3 is a natural number, 3 is a whole number and 3 is an integer. How can you say that 3 is a rational number? Yes, 3 can be rewritten as 3 by 1, where in the place of P, 3 has been substituted. In the place of Q, we have substituted with 1. Where 3 is an integer, 1 is also an integer and 1 does not equal to 0. That is why 3 is also a rational number. So I think you're clear with rational numbers. Again, I'll tell you. Rational numbers are numbers which are in the form of P by Q, where P and Q are integers and Q does not equal to 0. So any number can be represented as a rational number, that is in the form of P by Q. Now let us see properties of rational numbers. What is meant by properties of rational numbers? That is, few numbers have some characteristics. That's what we'll call it as properties of rational number. Now first we'll see closure property. What is meant by closure property? Closure property says that when we add or subtract or multiply or divide any two rational numbers, the resulting number will be a rational number. Again, I'll tell you, when we add or subtract or multiply or divide any two rational number, the resulting number will be a rational number. For example, let us take two rational numbers 3 by 2 and 2 by 2. So when we add 3 by 2 plus 2 by 2, we already know that it is a like fraction or like rational number since the denominators are same. So take a common denominator and add their numerators. So 3 by 2 plus 2 by 2 can be rewritten as 3 plus 2 the whole divided by 2. So 3 plus 2 will give you 5 and the denominator will be same as 2. So 5 by 2, which is a rational number since 2 is not equal to 0. Let us check whether it is the same condition when we subtract it. So while subtracting the same number 3 by 2 minus 2 by 2, so we'll get again the denominators are same. So 3 minus 2 the whole divided by 2, which will give you 1 by 2 again, which is a rational number. Now let us see multiplication. So 3 by 2 into 2 by 2. You need not to worry about multiplication whether it's a like rational number or a unlike rational number or like fractions or unlike fractions. Just multiply the numerator with numerator, denominator with denominator. So we will get 3 into 2 the whole divided by 2 into 2. So 3 2s are 6, 2 2s are 4. By reducing the terms using 2 table, 2 3s are 6 and 2 2s are 4. So we will get the answer as 3 by 2, which is also a rational number. So closure property is true for addition because whenever we add two numbers, we are getting two rational numbers. Whenever we subtract any two rational number, the resulting number is also a rational number. And in multiplication, whenever we multiply two rational number, again it's a rational number. The resulting number is a rational number. So for these three conditions, closure property is true in rational numbers. Whereas let us check in division. Before doing any kind of division, first let us see what is meant by reciprocal. Reciprocal is nothing but when a rational number or a fraction is given to you, interchanging the numerator as denominator and denominator as numerator is known as reciprocal. Again I'll tell you, reciprocal is nothing but interchanging the numerator as denominator and the denominator as the numerator is known as reciprocal. Reciprocal is otherwise known as multiplicative inverse. Reciprocal is otherwise known as multiplicative inverse. Now let us see. Example, reciprocal of 3 by 7. I already said in reciprocal you have to interchange the numerator as denominator and denominator as numerator. So 3 by 7 will be rewritten as 7 is the denominator. The reciprocal of 3 by 7 will be 7 by 3, where 7 becomes the numerator and 3 becomes the denominator. That is why reciprocal of any number will be just the reverse order of the same number. Now let us see division of rational numbers. Now we have two rational numbers 3 by 2 and 2 by 2. So 3 by 2 divided by 2 by 2. Same way, write the number as it is, 3 by 2 as it is, and we can't do anything with this division symbol with rational number. So in order to do some kind of operation, we will change this division symbol into multiplication. That is why we thought reciprocal here. Again I'll tell you, 3 by 2 divided by 2 by 2 will be rewritten as 3 by 2. The first number which precedes the division symbol will be as it is. So 3 by 2 will be as it is. This division symbol will be changed to multiplication. If something is changed, the other thing will be changed. So what will happen? This 2 by 2 will be again changed to the numerator 2 will be denominator 2, and the denominator 2 will be changed to the numerator. Since it's a same number, you will not be able to do it, or you will not be able to find it. Let me check with other number. 3 by 2 divided by 4 by 3. So what will happen? 3 by 2 will be as it is. Instead of this division symbol, I will change the symbol as multiplication. If I change the symbol as multiplication, the next number, the next rational number will be changed to its reciprocal. That is, 4 by 3 will become 3 by 4. Now multiply the numerators. 3 into 3 whole divided by 2 into 4, which will give you 3 3s are 9 by 8. So again we get a rational number. Here in this case, 2 by 2, since 2 by 2 is the same number, the reciprocal of 2 by 2 will be same, 2 by 2. So 3 2s are 6, 2 2s are 4. So 6 by 4 can be rewritten as 2 3s are 6, 2 2s are 4. So either you can write 6 by 4 as it is, or you can reduce it to its simplest form, 3 by 2. Now let us check the same closure property for all natural numbers, whole numbers, integers, rational numbers. Now let us take two numbers, 7 and 5. So let us add 7 plus 5. The answer is 12. Do we have 12 in natural numbers? Yes. So it's true. Do we have 12 in whole numbers? Yes. So this is also true. Do we have 12 in integers? Yes. So this is also true. And do we have 12 in the rational numbers? Yes. 12 can be rewritten as 12 by 1. 12 can be rewritten as 12 by 1. So yes. So closure property under addition is true for all the natural numbers, whole numbers, integers and rational numbers. Now let us see. 7 minus 5 equals to 2. 7 minus 5 equals to 2. What happens if I change this number? 7 minus 5, instead of 7 minus 5, if I have written 5 minus 7, what will happen? So 5 minus 7 equals to minus 2. 5 minus 7 will give you minus 2. Is minus 2 is a natural number? No, it's a negative number, so we don't have minus 2 in natural numbers. Is minus 2 is a whole number? Again, it's a no. Is minus 2 is an integer? Yes, it's an integer, so it's true. Is minus 2 is a rational number? Yes, it's a rational number, because minus 2 can be rewritten as minus 2 by 1. So it's true. So closure property under subtraction, it's not true for natural numbers and whole numbers, because whenever a bigger number is subtracted from a smaller number, you will get a negative number as your answer. So this will not work in natural numbers and whole numbers, since natural number and whole number, both numbers have only positive numbers, not negative numbers. Let us check multiplication. 7 5s are or 5 7s are, both will give you same answer, 35. Is 35 is a natural number? Yes. Is 35 is a whole number? Yes. Is 35 is an integer? Yes, it's a positive integer. And is rational number? Is 35 is a rational number? Yes, it's a rational number. So closure property under multiplication, it's true for all the numbers, natural numbers, whole numbers, integers and rational numbers. Next we'll go for division. So the same number 7 and 5, So I'm going to divide 7 by 5, which will give you 7 by 5. Is 7 by 5 is a natural number? No, it's not a natural number, because natural number will be a complete number. Is 7 by 5 is a whole number? Again, it's not a whole number. Is 7 by 5 is an integer? Again, it's not an integer. Is 7 by 5 is a rational number? Yes, it's a rational number where 7 can be considered as P and 5 can be considered as Q, where Q is not equal to 0. So 7 by 5 is a rational number. So when we divide any two rational numbers, the resulting number is a rational number. So in this, from this tabular column, what can we see? That closure property is true for all natural number, whole number, integers and rational numbers under addition, whereas it is not true for natural numbers and whole numbers under subtraction, but it's true for integers and rational numbers. Similarly, closure property is true for all the numbers under multiplication, whereas it's not true for division for natural numbers, whole numbers and integers, but it's true for rational numbers. So this is what closure property. What does it closure property says? When you add or subtract or multiply or divide any two rational number, the resulting number will be a rational number. Is 12 is a rational number? Yes. Is minus 2 is a rational number? Yes. Is 35 is a rational number? Yes. Is 7 by 5 is a rational number? Yes, it's a rational number. Now let us see what is meant by commutative property. So, like closure property, commutative property also deals with only two numbers. So what does it commutative property states? When we add or multiply or divide or subtract any two integers or rational numbers in any order, the result should not be changed. That is, if I say A plus B and if I interchange their places, instead of A if I write B and instead of B I write A, the resulting number should not be changed. That is what commutative property states. Commutative property states that when we add, subtract, multiply or divide any two rational numbers, the resulting number should not be changed when the same operation is done with the numbers interchanged its positions. That is, when we interchange the numbers and when we add or subtract, multiply or divide, the resulting number should not be changed. Let us check it out. In addition, subtraction and multiplication with two numbers 7 by 5 and 3 by 5. So what does it states? A plus B should be equal to B plus A. So what is the first number? 7 by 5. So 7 by 5 plus 3 by 5 is equals to 3 by 5 plus 7 by 5. Now you can see that 7 by 5 and 3 by 5 has been changed in their places. Here we have written 7 by 5 in the first place, but here 7 by 5 in the second place after the operation. So since the denominators are same, add the numerators with the common denominator. Write the common denominator as 5. So 7 plus 3 equals to 10. So 10 by 5 can be rewritten as 2. That is by cancellation. Similarly, 3 by 5 plus 7 by 5. So 3 plus 7, it's in the numerator since the denominators are same. So again 3 plus 7 will give you 10. So 10 by 5 is nothing but 2. Do we have the same numbers? Yes. So commutative property under addition is true. Commutative property under addition is true. Let us check with for subtraction. A minus B equals to B minus A. So 7 by 5 minus 3 by 5 is equals to 3 by 5 minus 7 by 5. What I have done, the same thing I have done over here, but slight changes. That is, here it is addition, but here it is subtraction. Same concept, since the denominators are same, subtract the numerators. 7 minus 3 is equals to, same here, 3 minus 7. 7 minus 3 will give you 4, but 3 minus 4 will give you minus 4. Is minus 4 and plus 4 are equal? No, they are not equal. So commutative property under subtraction doesn't work. Let us see for multiplication. A into B equals to B into A. 7 by 5 into 3 by 5 is equals to 3 by 5 into 7 by 5. So in multiplication you need not worry about anything, just multiply the numerator with numerator. So 7 3s are 21, denominator 5 into 5 equals to 25. Again 3 7s are 21, 5 5s are 25. So commutative property under multiplication works here. Now let us go for division. So A divided by B is equals to B divided by A. 7 divided by 5 divided by 3 by 5 is equals to 3 by 5 divided by 7 by 5. Same concept. So 7 by 5 will be as it is. This division symbol we can't do anything, so we are going to change it. Once we change this division symbol into multiplication, what will happen? Is reciprocal, that is the numerator will become the denominator and the denominator will become its numerator. So 3 will be the denominator, 5 will become its numerator, so it will be changed to 5 by 3. 3 by 5 has been changed to 5 by 3, which is equals to 3 by 5 will be as it is. This division symbol we can't do anything, so we are going to change it to multiplication. Once we change to multiplication, what will happen? 7 by 5 will be changed to 5 by 7. So 7, now cancel this 5. 5 ones are 5, 5 ones are 5. Under multiplication, the denominator and the numerator can be cancelled, you know this. So 7 ones are 7, 1 3s are 3. Similarly here 5 1 is 5, 5 1 is 5, so 3 1 is 3, 7 1 is 7. So 7 by 3 and 3 by 7 are not same. So division under commutative property does not work. Now let us check. Let us fill this tabular column. Commutative property. Let us take two rational numbers, 7 by 5, 7 and 9. Is 7 is a rational number? If so, say how it is. Is 9 is a rational number? If it is so, write how it becomes a rational number. Now first let us see for natural number. 7 plus 9 equals to 9 plus 7. Both gives 16. So addition under commutative property is true for all the numbers, natural numbers, whole numbers, integers and rational numbers. Similarly, 7 minus 9 will give you minus 2, whereas 9 minus 7 will give you 2. So subtraction under commutative property is not true for any of these numbers. Next, 7 9s are 63, 9 7s are 63. Both are same. So multiplication under commutative property is true for all the numbers. So division, 9 by 7 is not equal to 7 by 9. So it will not be true for division under commutative property. Commutative property will not be true for division and subtraction for any of these numbers, whereas it is true for addition and multiplication.